the mathematical tools. So in the trigonometry, we are taking the applications of trigonometry, or we will further going to explore the remaining part of the trigonometry. So let me start with first slide. The sine theta, sine of minus theta, what can be its value particular thing? I'll begin with already I have pre-written so that we can save time. Look at this thing here. So let me, initially the line is initially. So let it be here. So I'm going to rotate it to an angle theta. Then it will become OP. And they'll become like a triangle OP. OMP will become triangle. Here, so let POM, the angle POM is equal to P dash OM. Let that be equal to theta. Now, if you look at the angular measurement, this angle theta will measure in counterclockwise. So this should be positive. What about here? Angle MOP dash, it is measured in clockwise sense. So therefore, this angle measurement has to be taken as negative. So in this triangle, look at this one. In the triangle POM, okay, in the triangle POM, so the angle POM will become plus theta. In the triangle P dash OM or MOP dash in the triangle, anything P dash OM, so the angle MOP dash will become minus theta. Let me define sine theta. So it will be like a opposite by hypotenuse. The sine theta will be here opposite. This will be hypotenuse. So for the lower part of triangle, this will be opposite. This will be hypotenuse. Then this will be like, so in this particular triangle, sine theta, we can write it as MP by OP. Here, what you write, sine of minus theta should be equal to MP dash by OP dash. How MP dash? MP dash is measured along negative y-axis. What about MP? MP is measured along positive x-axis. So therefore, if you call this as positive MP, then MP dash should be negative. Negative of that, both will be of equal length. So therefore, MP dash is equal to minus of MP. I think this is one important try to notice here. And anyway, like as there's a circle, as we have a circle, so OP is equal to OP dash. So there's a part of a circle, what you are seeing. It's a part of a circle. So therefore, OP is equal to OP and OP dash will become like radius of circle. Agreed. This one. Okay, let's define the terms here like it's sine of sine theta, what we write MP by OP. Sine of minus theta will write MP dash by OP dash. And we know MP dash is equal to what we write it as minus MP. And MP by OP, what you'll write it as from this basic thing. So I'll define clearly here. Sine theta MP by OP. Sine of minus theta equal to MP dash by OP dash. Those triangles only we are just equating that. So in place of MP by OP, what you can write? Sine theta. In place of sine theta equal to, so I'll substitute this MP by OP equals sine theta. So sine of minus theta, what do we get? Finally, we'll end up with minus sine theta. Okay, there's a reason. There's a reason what we'll put it. Okay, let's come for cos theta. Cos theta, how you define in this triangle OMP. Cos theta equal to adjacent by hypotenuse. This will become adjacent. So cos theta will define that as adjacent by hypotenuse. Adjacent is OM, hypotenuse is OP. In this lower triangle, OMP dash, cos of minus theta should be equal to OM by OP dash. This is for which triangle? For triangle OMP. This is for triangle OP dash M. So therefore, what we can conclude here, cos theta is equal to minus sin theta. One more identity is what we have brought it. So cos theta equal cos of minus theta will become equal to cos theta. That is very important for us in the mathematical part when we go for it. Then afterwards, tan of minus theta should be minus tan theta. Cosecant of minus theta minus cosecant theta. Secant of minus theta, secant minus theta, secant theta. Cot of minus theta will be minus cos theta. There are other things also, you can prove it. Okay, let me, I summarize sin theta, cos theta. What is tan theta? Sin theta by cos theta. No? So from there we'll get the tan theta. So I'll go for the next thing. Sine of 90 minus theta, what conditions will come? So I assumed a triangle here. So try to look at this. There's a triangle we are taking, or I'll show that triangle. Okay, there's a triangle. Are you seeing this triangle? Yeah, then in this triangle, so what we define is, if this angle, let me define, let angle PMO theta, then there's a right angle triangle, so this will be 90 degrees. Then the other angle should be 90 minus theta, because sum of all three angles in the triangle should be 180 degrees. We'll define now this one's for I think now 90 minus theta, this will become adjacent, this will become opposite. For angle theta, this will become opposite side, this will become adjacent side. I think this is a very fundamental difference which you have to notice here. So what is this triangle? This triangle, they're the same, both the triangles, I'm just indicating in different way. Try to notice here. Now let's define in this triangle. Sine of 90 minus theta, what will write? Opposite by hypotenuse. So what is opposite for this yellow color triangle? It will be OM by PM. Fine, keep it here now. Similarly, in this triangle, we'll define what is cos theta, OM by PM. The bigger green triangle, this one. Cos theta, we'll define this as adjacent by hypotenuse. Then equating these two, OM by PM, OM, equating these two. So what do we get? Sine of 90 minus theta is what? Cos theta. Okay, there's one identity is what we have brought it. Let me highlight it. Similarly, cos of 90 minus theta, what it will be? Now let me go for this triangle again. Cos of 90 minus theta, adjacent by hypotenuse. So therefore, OP by PM, OP by PM. That sine theta in this, looking at this bigger triangle, sine theta, what we can write? OP by PM. Let me equate these two. So therefore, cos of 90 minus theta will be sine theta. So there's one more, this one. So cos of 90 minus theta should be equal to sine theta. Similarly, we'll explore these things. Cosecant of 90 minus theta will be secant theta. Secant of 90 minus theta will be cosecant theta. Tan of 90 minus theta, cos theta. Cot of 90 minus theta will be tan theta. So other thing, that this angle, this will become, what is 90 minus theta? This will come in the first quadrant. In the first quadrant, what should be the sine? Sine of 90 minus theta will become cos theta. That's what we are trying to express here. Cos of 90 minus theta will be sine theta. If you're not understanding this, what you are trying to do, we'll do one thing. Sine 60 degrees, how much? Root 3 by 2. Cos 30 is how much? Root 3 by 2. Sine 60, can we write it as? I'll just express what you are doing. We are not getting sine of 90 minus theta. What is the use of that? Suppose say sine 60 degrees is there. We know it is equal to sine 60. Can I write it as sine 90 minus sine 90 degrees minus sine 60 degrees? So this will become sine 90 cos 60 cos 90 sine 60. What is the value of this? Will simplify. Sine 90 is 1, cos 60 1 by 2. Cos 90 is 0, sine 60 root 3 by 2. The value of this is 1 by 2. Cos 30 degrees, we'll see. What do we get? Cos 30 degrees directly, also cos 60 degrees will sine 60. I ended up this one. No, cos 30, cos 60 will, cos 30 will see. I think somewhere I got stuck up. Let me check it. -90 minus 60, sine 90, cos 60, cos 90, sine A, cos B, cos A, sine B. No. Similarly, this cos 30, what is the value of cos 60? Cos 60 is 1 by 2. So therefore, what we can write here now? Sine of 90 minus 60 is what? Like theta, let me put 60 degrees. So sine of 90 minus 60, what will get 30 degrees. I'm just trying to prove something here. So sine of, or I'll push it here. This you're finding difficult. I'll take example. Sine of 90 minus theta degree. Let theta equal to 30 degrees. Why to sine of 90 minus 30, how much you get it? Sine 60, which is equal to how much? Root 3 by 2. Similarly, theta equal 30 degree, no? So cos theta, cos 30 degrees. So with this, what you can say? Sine 90 minus theta is equal to cos theta. That's what I wanted to show there earlier. This is what we are showing. Mathematically, we are showing it. Or you can use the compound angle and you can verify it. Let's take the next one. What is the value of sine of 90 plus theta? Sine of 90 degree plus theta. What it will be equal to? So there here. So what we do is like, there's a circle which I drew. Now we have a circle here. Then in the circle, you check it now. So this will be this what we're having a circle. Let me define first the angle here. So this angle POM in this triangle POM, the angle made by PO with horizontal, let it be theta. Agree this? Then let this rotate through an angle 90 degrees. Then OP dash will become perpendicular to the earlier position of OP, and that is equal to 90 degrees. I'll let it. So earlier, what happened initially, the line was making an angle. I do have method. I'll show this. So what was the angle it was making? Theta. Now I'll rotate it by 90 degrees. What is the angle made by this now? The arrow with the horizontal will be 90 plus theta. This is what we have done. So earlier it was here. So as this starts rotating, now OP will make an angle theta. Now if I further rotate by 90 degrees, how much of angle it will subtend with the x-axis? 90 plus theta. Then, okay, let me define the other triangles. So now, so what is the angle between OP and OP dash? That should be equal to 90 degrees. Now, if you look at this triangle OPM and OP dash M dash, they are congruent. So what do you mean by congruent? What do you mean by congruent? Congruent are like two triangles having same sides and same angles. They're said to be congruent. Only their orientation may be different. I have here, I'll do this one. So these two triangles are said to be congruent. These are called as congruent triangles. These are congruent triangles here. So they are same thing. The orientation is different. Able to, like you see this one, that this is just being its orientation is changed here. I'm not saying the side length has changed. What is the hypotenuse? The same hypotenuse. What was the base? This is a base. What was the height? This will become height. It got its orientation changed here. Example, this one. These two triangles are said to be congruent triangles. Okay, so therefore now the one which was base, now it will become height. I think still if you are not able to understand, I have here. There's a one triangle. There's a one triangle. So now let's take the so definitely they are congruent, no? Provided what is the condition? Provided what is condition? If this length is equal to, if this is X, this will be X. If this is Y, this will be Y. This is R, or so this is some R, so this will be R. If this is angle theta, let this be alpha, then this will be alpha, this will be theta. I think it's okay, no? Only the orientation of triangle changed here. So two triangles of same side length and the same angles are said to be congruent. So this is what we are seeing here. So all together now you are seeing this particular triangle. So OPM and OP dash M dash are congruent. This is very important. OM, let me define it as X. Then P dash M dash P dash will become X. Now I add this a circle. Add this a circle. I do that circle, no? So I did the circle. So OP should be equal to OP dash. No, MP is equal to Y. So then OM dash should be equal to Y. This MP, let me call it as Y. So then OM dash should be equal to Y. No, we wanted sine of 90 plus. How to bring? I'm going to take this bigger triangle. Look at this one here. OM P dash in the triangle OM P dash we have here. So let me just give some. I'll shade it so that you can. No, sine of 90 plus theta. So is it a right angle triangle? No, it's not a right angle triangle. So we'll apply a sine rule for it. Applying sine rule, sine of 90 plus theta should be equal to this side length is how much? P dash M. Sine 90 plus theta by this side P dash M should be equal to sine beta by OP dash. And what is OP dash? OP dash is R. It should be equal to radius of the circle, no? OP dash equal to OP equal to, we have here. That's what I indicated here. So I'm applying the sine rule. Sine of 90 plus theta is equal to P dash M. Sine of 90 plus theta divided by P dash M should be equal to sine beta by OP dash. Okay, let's keep it as it is. So sine 90 plus theta. Sine beta will define further. Some bigger triangle. I'm asking you to look at this bigger triangle. Yeah. What is that bigger triangle? P dash M dash M. Look at see this triangle. Sine beta, what you can write it as? Opposite by hypotenuse. So m dash p dash by p dash m. So what is m dash p dash is equal to x. Keep it here and p dash m as it is. Little bit. Don't try to simplify it. Now sine beta, shall we substitute this here? It will come like this. We'll replace here. Substituting that, then sine of 90 plus theta by p dash m is equal to OP dash. What is value of OP dash is equal to r. That will substitute. Sine beta is x by p dash m. P dash m get cancelled. So sine of 90 plus theta is equal to x by r. So what to do x by r? I'll come for this triangle. O, okay, or it's O m dash p dash. But we wanted like a sine of 90 plus theta equal to x by r, no? So here we'll define this is theta. Or you can choose anything, any of the triangle. This yellow color triangle, let me choose here. So what is cos theta? You can write it as. I written at different points so the students can think, okay, this may not be needed, this triangle. I'll erase it. Okay, unnecessary for you. I will take it out. This may not be needed. No, no. Look at this part. Here. Cos theta, what you can write? Adjacent OM by OP. OM is x by r. So what we needed, what is x by r? X by r, I can replace no here. So sine of 90 plus theta, finally what we end up? Equal to cos theta. Are you getting now? So like this is the everything through coordinate geometry it will come. We are not supposed to directly say like as our memorization. Everything there is some meaningful things are there. So sine of 90 plus theta is called cos theta. Similarly, we'll try for cos of 90 plus theta. You may wonder like, sir, why you are teaching all these things? So I could have written directly cos of 90 plus theta minus sine theta. Definitely you may think that how is writing? What is the reason for that? So many questions you'll start asking. So therefore, I'm just trying to derive those identities here. Now what is our next question? Find cos of 90 plus theta. What is the value of this? Again, the same triangle, what we assumed is the same set of diagram, I just took it. So this was the triangle. The same ideas, what all we just know we had, no, the same OP equal to OP dash, this triangle, OMP and OM dash P dash are congruent. Huh? Can you remember just now what we did? The same set of things is what I'm going to apply here. Now let me shade this triangle so that it'll be easy for you to look at. I'll say green triangle, look at green triangle. I say blue triangle, look at blue triangle. Let's get into the discussion now. Now what we want cos of 90 plus theta. So how to bring cos of 90 plus theta? I'll take help of cosine rule. So the side length, this P dash M whole square should be equal to OM square plus OP dash square minus 2 times of OM into OP dash cosine of angle between OM and OP dash. What is the angle between OM and OP dash? It's 90 plus theta, right? Cos of 90 plus theta. What is P dash M? Should be equal to R. OM is what we took, small x, and OP dash is what, capital R. I think that this length is what we took, small r. P dash M equal to small r. I don't have a place. Let me dump it here. No, come for this one. Let me substitute here. So OM we are defined equal to x, and OP dash is what? Equal to capital R, cos of 90 plus. Okay, somehow we have brought some one equation. Let's keep this as it is. Now let me come for the triangle. Triangle M dash P. M dash P, right angle triangle. There's a right angle triangle. So this angle, let it be beta. We'll define some angle. Let me call beta. Then in this here, what we can write? P dash m, Pythagoras theorem, let me apply. P dash m whole square should be equal to m dash whole square plus m dash p dash whole square. What is P dash m? R square. M dash x plus y, the total distance from m to m dash, because these two are again congruent. Triangle OMP and OM dash P dash are congruent. The same earlier. I'll write it. I don't have place. OMP and OM dash P dash are congruent triangles. So based on that, so that the sum of these two should be, if this is height, this will become base. The orientation of that has changed here. If this angle is theta, this will be theta. If this is alpha, this will be alpha. No, r square. So the x plus y whole square. So what is m dash? Should be x plus y whole square. What is m dash p? M dash p should be x square. Keep this in mind. Now, shall we substitute this r square value in this above equation? So we'll give the number. This is equation 1, equation 2. Put 2 in 1. I'm going to put equation 2 in equation 1. Then x plus y whole square plus x square. Here x square. What is r square? R square I can define from bigger triangle here. Or you can pick up any of this triangle. So what is r square? We can write it as x square plus y square. Or look at this r square, capital R square, x square plus y square. So we'll replace this one. R square as x square plus y square. Minus, this will be as 2xr cos 90 plus theta. Keep it here in. So we'll expand this a plus b whole square formula, x plus y whole square. So x square plus y square plus 2xy plus x square is equal to x square plus plus y square. This one. So now I think this x square will cancel. So what will be left over? 2xy minus 2xr cos of 90 plus theta. 2x get cancelled. So y is equal to minus r cos of 90 plus theta. So cos of 90 plus theta, let me write it as minus of y by r. Let me write it. So come for this triangle, the right triangle. Here, what is that? No. Can you define anything y by r? Sin theta is y by r. So in place of y by r, can we write it as sin theta? So therefore, what is cos of 90 plus theta will be minus sin theta. Getting the basic proof. So what was our question? Our question was to find out cos of 90 plus theta, how much? That's what I just shown. It is equal to, in fact, minus of sin theta. Sine rule, cosine rule. So when right angle